G'day everyone, welcome back to the second part of this series on the AWS Cloud Development Kit, or the CDK. In this one, we're going to be diving a little bit deeper into the next stages of building our application. Remember, we're building a backend stack that encapsulates a DynamoDB table to store information, to store data, an API gateway that's a way for users or other applications to interact with that data and retrieve useful bits of information or to store information. That API is kind of like the layer in front of everything, right? In front of the table and of course in front of our business logic layer. And our business logic layer is going to sit in something that we call a Lambda function. And a Lambda function is of course just a little piece of compute that runs your code for you. And that could be get something from a database, store something from a database, transform a hash, do these little sort of basic operations that you might need to do in your application, right? We're going to do a little bit of house cleaning before we jump into writing that business logic layer, but most of this second part here will be based around just writing out that business logic piece, and then we can dive into the rest of this and start deploying it also. So one thing I quickly want to add here is we need to add in some routes on our API. If you think about a REST API traditionally, it'll have routes like /user or /sales or these sort of things that help whoever's consuming that data from the outside understand what it is they're even getting, right? They want to know if they're actually getting a user or getting some sale data. So it's really important that we have this so that that interface can be very well understood and defined, right? That contract between the API and of course whoever's consuming it is critical that it's upheld and made really nice. So let's go ahead and start adding that in. So we say API gateway and we want to say add routes. Now routes are of course just the way in which we do this. And with this add routes method on API gateway, it just allows us to define them very easy in like a declarative way. So the integration here is like, okay, of course, you're going to have a path on a route, which we'll get to in a second. But like, what happens when this route gets hit? Do I, send a message to a queue? Do I run a Lambda function? Yes, in our case. Do I proxy it to another API? Right? You can do all sorts of stuff with API gateway. So it's important to understand what is the actual integration here, right? What's actually going to happen? And for us, we have HTTP Lambda integration. Like this is what we're actually going to be using. This is, as the name suggests, it's an integration to run a Lambda function over HTTP. And so what we'll do is we'll call this, this is going to be our list sales handler, or our route rather. Let's call it our list sales route. And this takes as a second arg, so as soon as you hit comma here, you can see that the second argument is a handler. So we pass in our handler function, and then that's pretty much all we need for that line there. Now, there's other args you can pass in the options like a payload format or some mappings or timeouts, but we don't really need that sort of stuff yet, right? So another thing we need to define is the path. And because this is going to be a route to list all sales, we can define the path as /sales. But let's do list sales because that makes way more sense, right? Listing sales. And let's take this one step further. I mean, listing all sales for a platform kind of seems pointless, right? Really what you want to do is you want to list the sales for a certain user, most likely. So let's say that this is going to take a user ID. You need to pass in a user ID to actually get all the sales for that user. That makes sense, right? And that's a sort of typical pattern, whether it's users or items or sales or images or whatever it is your API does. Typically, you might want to like grab a subset of them for a certain user or an action or whatever it is. And now in this methods section here, we can say that we only want to allow a get method here, right? This makes sense. So now we have a route that's defined. When anyone calls list sales with user ID here, then that will run our handler function. Our handler function doesn't yet exist, right? We've defined all this structure here for the table, the gateway, the handler function, and now we're adding the routes, but we still haven't made the main TS anyway yet. We're going to do that in a moment. So API gateway, add routes. Let's add in a way to, we're going to use the same structure there. So this is a create sale route now. Let's create a way to create a sale, right? And Copilot knows we want to do this because it's kind of obvious. Like if you have a list sales, you might want to have a get sale, which I'm sure it's probably going to recommend next, and a create sale. So the path here is going to be, let's just call it sale, and we'll post to this. So the method is going to be a post, and this will be a way for us to create a sale. You could have a create sale, just to sort of keep it in line with list sale. Let's do it actually, just to sort of keep it nice and keep it nice. So, I mean, there's so many things when it comes to routes, and we're going to talk about DynamoDB table design here in a moment as well, where it's like, oh, we do it like this, or we prefer to do it like this. There's really no hard and fast rule for a lot of these things. You could have sail, which allows you to call get or post, and then by the method you would know it, or you could have get sail and create sail. Stuff like that, it's really up to you. I think a lot of the time it's important to just consider that you're building something to show value and not to get caught up in semantics. When you take something to production, it's good to rip it all down and say like, okay, like let's productionize this. Let's put authorizers. Let's do this properly. Let's do really well architected components and stuff like that. And the gap from the way we're doing it to that is not much. It's not much. So get sail route. This is going to be for getting a single sail. That's a path on get sail, and then we have to pass in a sail ID. That's fine there. Now, the methods here are get, and as I just said a second ago, you can see here there's another property called authorizer, and that allows you to basically define an authorizer that you would have to successfully validate against to be able to sort of access this API endpoint, right? So you could do it on create sail for something like, there's no way you want someone to just be able to hit create sail and post in there. Typically you want that behind auth. Something like a JWT authorizer is a very good way to go there. So you can ensure that only people who are allowed to hit it are hitting it. So authorizers are great. And you would definitely use them in production, but in here we're just going to skip it for now. So this is going to be a public API with no auth. This is looking good. I'm pretty happy with this. We got list sales for a user, we got create sale, and we've got get sale by a certain sale ID. So this allows us to get all sales, and then we can look up a single sale. This allows us to create a sale. So this is going to take a body, which allows us to pass in information about the sale, and this will take the path parameter and a path parameter also. All right, I think that's looking pretty good. They're all going to call the same function, and this is an important thing to note because when you're building Lambda functions, typically when you're prototyping or trying to show business value or build out your first, startup or SaaS product, you don't need like a route per function. You don't need like a method per function or anything like that. You can completely go overboard and create different Lambda functions with like different amounts of memory and different code bases for each specific function. Or each specific route or method. But a lot of the time, that's just overkill. I'd say 90% of applications that I see that are doing this pattern, which is incredibly common, API, table, and then business logic layer, you really only need a single Lambda function. That's going to scale incredibly well out of the box by design, and you do not need to worry about it. Most Lambda scaling rules anyway are on an account-based level when it comes to AWS. So you don't really need to think about that. You just sort of build a single Lambda, monitor it, make sure you're not getting any throttles. If you did somehow get throttles, work out what the hot path is, migrate that to a different Lambda, maybe migrate that to a different account, or even have extending on your account limits if you need to really increase the scalability. But I don't think that happens very often, and this is an incredibly scalable and efficient way to go. So, looking good, looking good. I think we've got these routes here all defined nicely. We've got the handler, we've got the API gateway, we've got the table. Everything's looking sweet. So now it's time for us to define this Lambda function. So let's jump over and create a source folder. Now, why did I create a source folder? If you look at the handler function here, source main TS. Let's keep that separate away from everything else, that main TS. And then we need to define a function there called handler, which is going to be exported, that Lambda can then execute on our behalf or on the request of the user that's coming through. And that will handle the rest of the flow for us. So let's go ahead in here. Let's call this main.ts. And we're going to start writing some code in here. Now, let's write some stuff in here. So let's just say const handler. We know it has to be called handler. Equals async event promise any. Sure, like this is an okay starting point, and it gives you just the handler structure. And then here's Copilot trying to be tricky and give you some more stuff, which we don't need. We do need, however, to export the handler. So let's just do that real quickly. So the handler is now exported out, and then that can be called. Like we said, we have to export it out of here. But I'm not really a fan of these types. And if you're writing TypeScript, for the love of God, do not use any. It's very easy to avoid. So what we actually need is we need to use a library in TypeScript to actually understand what these types are. There's a library called AWS-Lambda types, which has all of these built-in types that allows you to really understand, okay, well, I'm working with API Gateway, so I'm expecting this event. Or I'm working with SQS, so I'm expecting this event. Otherwise, it's kind of annoying. You have to do like, okay, well, I'm gonna like print out the event every time just so I can see what it is, and then I'm gonna come back and make a type and blah 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 blah. That is really annoying and frustrating. So you're best off just always using the right types. And so let's go and get those. So let's open a terminal here, and let's just say, let's go into the source directory that we created. Let's do an npm init-y because we need to install some stuff from npm, some modules. And so we need a package.json to store those. And then let's do npm install save types / AWS Lambda, which will give us all of these awesome types. So now that's been installed, we should be able to get rid of this any and also this any here. What this is actually going to become is an API gateway proxy event, or event, it's a API gateway proxy event v2. So we're using v2 here, and if I double click this, we should be able to get some IntelliSense. Not yet. Let's just import this and see if that wakes things up. And so from here, we should be able to get the API gateway proxy event v2. Here it is. There it is right there. What did I do? I spelled that wrong? Yes, I did. Okay, there we go. So that's the type we want. And if you look now on event, you'll see like, oh, there's also all this stuff here, right? This is exactly, we know exactly what we're going to get as this comes through from the API now. Remember, it's important to know that this Lambda has to respond back to API Gateway. This is not the Lambda that's responding back to the user. It responds to API Gateway, and API Gateway responds back to the user. So it truly is the proxy compute layer between whatever services we want on the back end in AWS and API Gateway as the front, right? Which is why we have this API Gateway event. So API Gateway proxy event, or proxy result. There we go, result v2. So this is what we're going to return from here. And of course, it's going to be red right now because we're not returning anything yet. So that's looking good though. And so I always keep this here just as a debug while we're doing debug. There we go. I always keep it here just as like, you never know, you might miss something and you might want to just see what the payload looks like. This is really good just for debug testing. Of course, in production, you won't do this. You'll have a logger and you'll do all fancy logging. So Copilot's saying here, yeah, just return 200 and stringify a body and hello world, and then you're done, right? But that's not really what we want to do here. We've got these routes that we created, like list sales, create sale, get sale, that sort of stuff. So let's build it, with some best practices in mind. I'm going to keep this kind of high level to avoid sort of going on for hours here. But what I always like to do is a switch statement here, because like I said before, you are going to have a single Lambda that services all of these different API routes. And you can see Copilot here being quite clever, and it says like, yeah, I know that you defined a list sales in the infrastructure stack, in the backend stack, so I'm going to put it here for you, which is fantastic. I've got a create sales here, a return sale, a get sale, and that's all looking well and good, right? This is actually quite nice because it really gives us a way to understand, when this path is the one that's being hit, then I want to run this code. When it's this path, I want to run this code. So I really like this way of doing it. There's going to be one minor change that I want to add here. I actually don't want to switch on the raw path just yet. I like to split this up one level deeper as well, just so that we have a more modular approach, because I don't want the handler to have all of that logic in there. So I'm going to actually switch on the event. So what we're actually going to do is we're going to switch on the method, right? So that's in the request context HTTP method, like this. And then this gives us an even nicer high-level abstraction where we can then have two separate functions that deal with our methods, or n amount, right, if we add more methods. And so get here is going to be for handling all of the different gets, right? And so this is going to be implement get method, and then this is simply going to be implement post method, right? And then this can be a 405 for unsupported method. So this makes more sense to me. I like this structure a little bit better. And then we can do a const handle get request. And we can do a const handle post request. boom, 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 like this. Now these are the ones that are going to actually switch on the specific routes, right? So if we add in these here, so list sales, for example, create sale is not going to be in here because that's not a GET request, but get sale is. So these will actually be, very suited to being inside this function. And what it allows us to do as well is it allows us to have just another layer of modularity. And it's just an easy way to come in here and extend one thing without having to change the actual main handler. Because this can always be await, return, handle, get request with the whole thing. Oops, this is return in front. And then this is return, await, handle, post request. Just keeps that so nice and simple. Like the business logic here never has to change. If you want to add put, you just case put, handle put request. Done. It's simple. And then of course in the actual pieces, you start to put in the these bits here. And so this is our create sale. That's the only post that we have. So that's the only one that's going to live in here. And then that makes sense, right? Now this is all structured super nicely. So then even again in here, what I like to do is I like to say the handle list sale function and handle get sale function, because these are the actual functions that we want to make very modular and export out of here, right? Not these high level ones. This is just kind of plumbing. So const list sales. I don't know why that's returning an any, but it's not going to return an any. We'll make a sales object in a moment. Const, let's say get sale. So that's just going to be for returning a single sale. And const create sale. So now we have these. Now these are the ones we care about. These are the ones that we export out and we write tests for, because this is the actual business logic. The rest of this stuff up here, all plumbing to make sure the business logic is called correctly and it's structured, it's extensible. If someone else came in and saw this code, it's very easy to read and very easy to understand. So I always recommend putting that first of mind. You don't want to just write everything in the handler. And ideally even, you might want to put this stuff into different files and import it in here as well. That's also totally fine. So these are now all very well structured and very obvious. So what we're going to do here is in here, we say return, await, and then list sales, return, await, get sale, right? Now these things here are red, which we'll get to in a second. Let's go and fix up this. This is going to be for return, await, create sale. Super easy. So now we need to get to the part where we're like thinking about making sure that the API has the correct input to run these functions. So you can see here it's saying like, well, it's possible that this is undefined. Now, what you can actually do on the infrastructure side is you can do some parameter mapping to ensure that certain things are required. So you can say, oh, if the API doesn't receive a user ID in the path parameter, then it's completely invalid. And you can have the API gateway reject that, which is actually a really good way of going in production so that it doesn't hit your business logic layer. But let's, for the sake of time here, let's just do basically, if there's no path parameters, or there is no path parameter on the user ID, we should just say user ID is required. You really need to pass a user ID if you're going to call list sales. Otherwise, this function is not going to do anything, right? So similarly with get sale, let's say that if there's no path parameter or there's no path parameter for sale ID, then we should return, hey, sale ID is required, right? So these two, they are both require their own sort of information in order to run them. And so therefore we want to make this check here. Now this is going to be guaranteed to be a string at this point, or at least it's going to be guaranteed to be something at this point because we've checked to see that it's there before we continue. So this is a good way to go. And so then we can do the same here with this, and this is what we need to check for in a body, right? So if there's no event body, then we need to basically throw that the body should be there, and then we actually parse the body into create sale, and then create sale can sort of expect a sale object, right? Now this is a little bit loose here, and in the interest of time, we won't spend too much time on it, but of course, you would want to use a library like Zod to actually validate that the body is correct. You never really want to just sort of parse and hope for the best. This is why we have tools like Zod for schema validation, making sure things are exactly as they are said they are. So that's what we need to do in TypeScript anyway. So that's looking good at a high level. So then we can start to think about, all right, now these are set, like these will be called correctly. Now we need to like implement the logic here for this. And we're going to need to bring in DynamoDB here. Like DynamoDB is basically how we're going to interact with the tables. So let's go ahead and bring DynamoDB in. So at the top, we're going to need to import these. So we're going to import Dynamo up here. But first, we need to install Dynamo because we don't have it yet. So we're going to need to install the different libraries that are used for DynamoDB. So we can do that by just saying npm install, and this is going to be, it's the AWS CDK / Dynamo client-DynamoDB. That's the client that we're going to use to interact with DynamoDB. And then there's also one called SDK lib Dynamo, which is all of the different types and input types and the way that we interact with the database, like all the different things that we need, like the commands and stuff like that. So that's really important also. So we're going to have both of those. So if we go over and we don't want this, we want this client DynamoDB, then this is going to give us the, let's say DynamoDB client, this thing here. That's the first step. And then we need the other stuff, right? The other stuff. So this is from the AWS CDK lib DynamoDB. And here we start to think about what we need to bring in. Like I'm going to need to do a GET request on the database because I'm going to get a single sale. I'm going to need to get a query because I want to list all sales. I'm going to need to put, the different things that we want to do in Dynamo. So get command input. That's the type that we want to get something from DynamoDB. Query command input, and put command and put command input. I think that's pretty much everything we need. We also need the document client itself. Document client. This is the DynamoDB document client, this one here. And the document client is basically a lightweight wrapper around the DynamoDB client that allows you to access the API at a bit of a more of an abstracted level. It's just a bit of an easier way of working. So here you can see the Dynamo client is getting created. We don't really need to pass in the region because it can just be inferred from the Lambda function itself. Here we can create a document client, right? So the document client's just created from the main client, and then you won't use the main client anymore. The document client is everything you need. And that's pretty much it. I think, we've got all this stuff up here, and we've got the client itself. So now we can go ahead and use the client. So remember, all these down here are just a way for us to call out things like get sale, list sale, and create sale in the post stuff. And so this is all good. Now let's go ahead and implement some of these. And so here we're getting a recommendation from Copilot already, which is pretty close to what we want. It's not bad, Copilot. It's not bad. Let's use it as a starting point. And so what we actually want to do here is, so it's basically saying like the key condition expression. So we want to find everything for a certain user ID, but this implies that our key conditions, like our primary key, is user ID. Now, what I like to do is I like to use the primary key of PK, and then just look it up like that. So I know our primary key right now is actually ID, and let's just quickly go back and change that because I don't really like that specifically. We'll just go with primary key of PK. And let's also, while we're here, make a sort key of SK. Now, why I want to do this is because we're going to need to query the table, and if you queried the table only on one thing, you would only have one dimension or one key to look it up on. So let's say if our primary key was user, and we just put all user IDs in there, then I could query on just on that user. But what I actually want is, like, I want the user to be the primary key, for example, but then the sort key could be like their profile, or it could be their sales, or it could be their receipts. Like, it could be anything, right? And that allows us to have like an extra dimension that we can sort of look things up on. So that's really important to do that. So now what we can do here is that we can just simply say like, okay, well, the PK is going to be the user ID. That is actually correct. We are going to use the PK as a user ID. So for the sort key here, let's go ahead and add in a sort key, and it's going to give us this of sale here. So sale is something that, because we're listing all sales for a certain user, we know that all sales are going to start with sale and then number, right? So let's say sale number 1 for user ABC is going to be sale #1. Sale 2 would be sale #2. So we can say that the sort key is just sale hash, and then up here we say and begins with SK. So this is a little bit tricky to understand at first with Dynamo, but really all we're looking for here is give me something where the PK, so the primary key, which we know we have on the table, is equal to the value of PK, and here we're defining the value, user ID, so that gets slotted in here, and it begins with SK. Oh, well, all of our sales are going to be with sale, right? So we have like created a way now to query for sales for a certain user. If this was for like cars, it could be cars or car, right? And then I could list all cars for a certain user or whatever else we store in the sort key. And so this is a simple way to do single table design. And then you can also have global secondary indexes and a bunch of other stuff, which is for another video. So this is a good way to do it. And then this is items down below here is going to return to us all sale items for this. All right, that's looking pretty damn good. Let's go ahead and add in our get sale here. So get sale is going to be a very simple one that allows us to basically send a command off to DynamoDB with a certain sale ID. And when you're actually doing a get command on Dynamo, you actually need to pass in the exact sale ID that you're looking for. Now, in this case, for us, what we are needing to do is, because our primary key is always a user ID, we need to know the user ID as well to get the sale. So you can't just look something up directly with the ID of the sale. So what we're going to do is we're going to extend this to take in a user ID and a sale ID, just so that we have both of those. Again, you wouldn't typically do this because you would have this as the value that you want, right? So let's go ahead, and it would be in the claims, right? So let's go sale ID. So sale, something like this is totally fine. This would allow you to look up a single item via the user ID and via the specific sale ID that you're looking for. And it would not allow you to leak the structure of the database in any sort of way. So this looks good to me. You've got a get sale there, and now create sale. We're going to basically insert the primary key as the user ID. And we're going to then have a sale item here of a certain sale ID. And then anything else that comes in as sale, we will then sort of pass in as the object there as well. And then you get sale created. So one issue with a lot of this here is we don't have a sale object. So let's go ahead and just create this type. So const sale, let's just type sale. Sale equals, let's give this some data, user ID, a sale ID, an amount, and a date. I think that's fine. So let's give that a name as well, and then this is looking good. Sale is pretty much a global type here that we can use. We can export it out of here. We can use it in other things as well, but it's pretty much everything we need to understand how it's all going to work. And so when we actually pass in the item here into sale, we're going to make sure that that is coming in as a sale like this. And then that makes sense, right? So then we've got this specifically in here and we know exactly what's there. And so let's go ahead and do that. And so we saw up here we had one more thing to fix. So this is get sale. We actually need the user ID as well. So we're not gonna again, this would come from JWT claims. Typically, this is not something that you would ever do exactly like this, but let's just do it like this. For example, user ID is a query string parameter. If there's no user ID, then return, and we just get it out of here like this. So you have to pass in a user ID on the query string when you are doing a get sale, just for the sake of this video. Okay, so that gives us a way to call get sale, a way to call list sale, a way to create a sale. I think we're all pretty much good. I think we're ready to deploy this. So let's conclude this video here, and we'll pick that up in the next one. If we just collapse everything here, we can have a quick look at everything before we wrap this thing up. So we've got our three main core pieces of business logic down here: list sale, get sale, create sale. And then we've got sort of the plumbing or wrappers around thing, right? Like this is the whole main handler that's used for entry point. All get requests come here, all post requests come here. And these functions down the bottom here, they need a little tiny bit of work on them still. So you can see that this is basically needs to be an array of sales. And what we're going to do is, again, we're going to just basically say that items, we'll do it like this, as items is a array of sales. We're going to hard cast it like this. Again, we know that the structure is in here. You could use Zod to validate this, but our table is going to have sort of a very strict structure around it anyway. But always use Zod to validate things if you are doing things unstructured and you're unsure of what's going to be there. But in this case, we are most likely only going to get sales because of the sort key being sale. So we can pretty much assure that it's this structure. Get item here, this is going to be as a single sale. So this should return a sale out of here, which is good. And when we do this, let's return the sale out of here that we created, which is pretty much this item here. And so what we could do is we can say const sale equals this, and we just pass this in here. So let's just say like this is our own version of the sale, which we pass in as the item there. Of course, we're passing in the sale as it's coming in from the body, but that doesn't have things like in the exact sort of structure that we want them here. And so what we can do is sort of keep the whole platform like returning the same structure as we sort of go, right? Because this sale here is actually what will be kind of in the database, which is what the other ones also return. So this is looking nice, and we have a nice structure on things. We have a little tiny error to fix up, which is just here. When we return this is returning a sale, but we need this to actually not return, we need this to actually return an API gateway response, right? So let's say this is the sales into here, and then we return the actual sales out of here. I like this more because you actually explicitly get to see what is being stored here before it sort of goes out. You know, this makes a bit more sense to me. And this is the sale, and then you can of course return that, and then we do the same right here. So this is const create sale. It just becomes even easier to read and to understand and to reason with, and create sale, like we can also just call this sale here, because that is going to return the sale also. That's looking really good. I'm really happy with this. It seems like a very straightforward, simple, abstracted, modular, easy to test way to build your API. And you can start to see how it's all coming together. So that's it for this video. In the next one, we'll deploy this, we'll test it, and we'll go through the sort of the final part of understanding how all the pieces fit together. All right, thank you very much.